Okay, we're going to just find some more partial derivatives here. So this is a slightly more complicated example than the last one we looked at. All right, so we're just going to find a partial derivative of this function with respect to x and then with respect to y. So the first thing I pay attention to here is where are my variables, where are my x's for the partial derivative with respect to x, and how are they connected to each other. So when I'm finding that partial derivative of f with respect to x, I'm zeroing in on the x's that are here. This is all one big term of this function. There's not any addition or subtraction that's separating this into kind of separate terms that I can almost treat as separate little pieces to the problem. So I've got x in here twice. Both of those x's are inside other functions. Here I've got an x inside a cosine function. Here I've got an x inside a square, which is inside the exponential function. So I've got x's inside other functions, and then the other relevant thing here is that those functions that they are inside are times each other. So I'm going to have to use some product rule, and there's how I would group for my product. All right, so when I find that partial derivative of f with respect to x, if in Calculus 1 you were taught to find derivatives by writing out a whole bunch of scratch work instead of just thinking through the rules and writing down the derivatives, you may need more practice here. You shouldn't need to write out a bunch of scratch work here. You're just thinking through your chain rule and your product rule. All right, the overall structure of this problem is going to be product rule. So when I do product rule, I often think about the derivative of the first function times the second function plus the first function times the derivative of the second function. And then when I do these derivatives parts here, I may need to use chain rule because I've got functions inside other functions when I do those derivatives here. Okay, so when I start, I'm just using this structure and maybe these labels to help you start. The other thing that's easy to do, especially when you're doing a complicated problem like this that involves product rule and two chain rules, is that it can be very easy to lose track of which thing you were differentiating with respect to. So if you get stuck on that, my advice would be to do exactly what I did here, which is circle the thing that you're treating as a variable so that you don't lose track of what you're treating as a variable. Okay, so derivative of exponential function is itself. Derivative of e to the x squared is e to the x squared, and then times the derivative of what's inside that exponential function. So the derivative of x squared is 2x. So that's chain rule on derivative of e to the x squared. Derivative of the first function times the second function, I'm just leaving this alone, plus the first function, again, just leaving that alone. And then here times the derivative of the second function. So here I'm going to need chain rule again, and because I have x's and y's in here, I have to be careful and be clear about what I'm treating as a variable and what I'm treating as constant. Okay, so the outer function here is the cosine function. The derivative of the cosine function is the negative sine function. So negative sine of just this expression, and then times the derivative of what's inside there. So again, remember I'm differentiating with respect to x. So I'm treating y as a constant. So this inner function here is just like having a constant times x. So just like you had 5x. So if I think about the derivative of 5x, let me just write that over here. The derivative of 5x is just 5. You probably remember that rule from Calc 1. Most students do. It's just a matter of connecting it to what we're doing here. So the inside function inside the cosine function is constant times x. The derivative of that would just be the constant, this rule, but my constant inside there would be y squared. Okay, so at that point, I have found my partial derivative with respect to x. Maybe you want to tidy that up a little bit. Certainly, if you were going to do something like set that derivative equal to 0, or plug in some numbers, or find a second derivative, you might want to tidy this up a little bit. If you're just finding a derivative and you don't care about simplifying, you could actually stop right there. I am going to go ahead and simplify this. So I would probably write the 2x out front times e to the x squared cosine of xy squared. And then all this is one term, so I'm going to put a minus. I'll probably put the y squared out front. Y squared e to the x squared times sine of xy squared. Okay, so there's our partial derivative of f with respect to x. All right, now I want to find the partial derivative of f with respect to y. So I'm going to go back to my original function. I'm going to focus in on where are the y's and how are they connected to everything else. And the first thing I'm going to notice on this one is, yay, I have only one y. Y is only in that function once, which means I don't need product rule here. I can think about this as if I had a constant, if I'm treating x as a constant, then e to the x squared would also be a constant times cosine of a constant times y squared, some other constant. I'll put c for another constant, times y squared. Right, so I'm treating that as if I have a constant times cosine of some constant times another function here. So when I do my partial derivative of f with respect to y, I don't need product rule. And I shouldn't write out product rule because that's a whole lot of wasted steps. And especially when we get to applications of the derivative, that's where all your time should be spent, is figuring out what to do with these derivatives and what they're telling you about the function. Okay, so I only have one y in there. So when I find my partial derivative with respect to y, this e to the x squared out front will be a constant. So when I'm differentiating a constant times a function, that constant just comes right along. So e to the x squared is a constant multiple rule. Constant. And then times the derivative of the cosine function. The derivative of the cosine function is the negative sine function of what's inside there. And then I do need some chain rule. I don't just have y inside here. I've got a function involving y. So I need to take this times the derivative of what's inside. Again, remember, now I'm differentiating with respect to y. So this is just like I have constant times y squared. Bring down your exponent and subtract 1. So I'll have 2x times y to the first. Okay, and then that's all just one term. If I want to clean that up a little bit, I'm going to put the minus sign out front. Negative 2xy times e to the x squared times sine of xy squared. For your online homework, it should not care if you simplify or not. So if you write a messy thing here with a bunch of parentheses and it is correct, your online homework should recognize that it is the same as your simplified version. So it is tricky sometimes to make sure that if you open a parentheses that you remember to close the parentheses and things like that. But you don't have to worry about the simplification. So if you want to be able to focus on, am I just finding the derivative correctly without worrying about simplification, when you do that online homework, it's perfectly fine to go ahead and type this in. And if it counts that right, then you know you're finding the derivative correctly, and then the rest of it's kind of just algebra and tidying that up. All right, so we're going to look at some other examples and some other videos of being able to find second derivatives. So derivatives of derivatives. So certainly it's important that you can find first derivatives correctly if you're going to use them to then find second derivatives. So make sure you practice enough of this with kind of all different types of functions, logarithms, trig functions, inverse trig functions, exponential functions, product rule, quotient rule, chain rule, to review all of those derivative rules that you learned from Calc 1 before you go on to do some of those applications.